What we are looking at today is the graphs of the sine and cosine function. Now, what you see here on this opening screen is our unit circle. And so what I did is I did a little bit of color coordinating. I did all of the radians in purple. I did all of the X values in blue, and I did all of the Y values in red. And the reason that that's going to matter today is because we know when we look at this that we are going to actually do. Excuse me one second. I forgot to erase this from my mess up last that I already had. I already had some technical difficulties this morning, so I apologize. Anyway, sorry about that. So when I look at this, the sine value or the sine function is directly connected to our y values in our graph. Okay, so if we look at our unit circle, our y values, we're going to look at just the reds around here. And I'm going to start with the ones that are on the axis. Okay, so I know if I've gone 0 radians, I've gone 0 on my y. So 0 radians gives me 0. If I come back to this and I look up here at the top, pi over 2, I'm going to be at a y value of 1. So that means at pi over 2, I'm actually going to change my axes here. At pi over 2, I'm going to be up 1. If I go all the way around the circle to pi, I'm now going to be at 0. So again, I can come over here, and at pi, I'm going to be at 0. And then at 3 pi over 2, down here, I'm going to be at negative 1. So 3 pi over 2, I'm at negative 1. And if I go all the way around to 2 pi, I'm back to 0. Now, the same concept could be used in reverse. So in other words, if I'm going negative pi over 2, I'm at negative 1. So negative pi over 2, I'm at negative 1. If I keep going to negative pi, I'm at 0. So negative pi, I'm at 0. And then I can keep on going to pi over 2, I'm at 1. So negative 3 pi over 2, I'm at 1. And then all the way around, I'm back at 0. And so I can go ahead and connect these. I could plot all of the points in between in the first, second, third, and fourth quadrant. But these are kind of the major points because here now it takes on a curve. And we know, oops, sorry about that. I kind of jerked a little bit. We know that we can continue to go around and around and around that circle forever and keep on going. So we're going to go ahead and add arrows there at the end. So we know that our domain, since we can go on forever in this graph left and right, is going to be negative infinity to positive infinity. Our range fluctuates from negative 1 to positive 1, and it includes those values. So we're going to use those brackets. It is continuous. Symmetric is, yes, it is symmetric. And if you look at this, it's rotational around the origin. So that means that it is odd. Increasing versus decreasing. It is actually both. And so I'm going to put both. And this is considered in periodic waves. We're going to talk about periods more later. So in periodic waves, bounded, it is bounded both above and below because it will never cross 1 or negative 1. The maxes and mins are actually negative 1 and positive 1. Horizontal asymptotes, you actually don't have any because it doesn't get closer and closer and closer and closer without crossing. It just is bouncing back and forth. Your vertical asymptotes, you actually have none. And then for your limits or for your end behaviors, your limits do not exist. And that's because, again, there's no set number that it's approaching. It's not getting smaller without bound. It's not getting bigger without bound. There's no asymptote it's approaching. It's just bouncing back and forth. So now when we take a look at the cosine is very similar, except for instead of looking at your y values, you are looking at your x's from your unit circle. So now as we look at this, I'm going to erase this circle here in the middle. Now we're looking at your x's. So if we haven't gone anywhere yet, we are up 1. And so if we look at this, we are, again, I'm going to go ahead and change my values. I'm up 1. Here, if I go all the way around this circle, I'm right back to where I started. If I go pi over 2, I'm at 0. So pi over 2, I'm at 0. If I go all the way to pi, I'm at negative 1. So if I go all the way to pi, I'm at negative 1. 3 pi over 2, if I look at this, is going to take me back to 0. And so I'm good there. Now, if you notice, we're going to go opposite the same direction. Or if we go the opposite direction, it's the same concept. So negative pi over 2 is going to be at 0. So negative pi over 2 is at 0. If we come back here to negative pi, I'm back at -1. And then I can continue on, and I'm going to go ahead and fill these gaps in. And again, I'm going to go ahead, I'm going to try that again. Don't be super perfect. I'm just a little OCD on this first one, especially to get you guys a look of what this is going to actually look like. Okay. So those are going to bounce back and forth. So it's a similar curve. It's just going to be starting in a different location. So again, your domain is going to be -infinity to +infinity. Your range is going to be the same. It's -1 to +1. It is continuous. It is symmetric, except for in this case, you can fold it around the y-axis, which means that it's going to be even. And then all the rest of this is the same for, I'm just going to put same as sine. So it's exactly the same in terms of if it's bounded, if there's max and mins, if there's horizontal asymptotes, all of that is exactly the same. So now when you look at the back here, I mentioned a second ago that the wave was periodic. So what a period is the length of one full cycle. Okay, so I'm going to put this here. Period is the length of one full cycle. So for example, if you look at our graph, how long does it take to get back to the original? So here going upwards and here going upwards, this took us a length or an amount of 2 pi to get back to that beginning of the cycle. You can think about it again in terms of your unit circle. It took us all the way around 2 pi to get us back to the beginning. So in other words, when we look at sine and cosine functions, they have a period of 2 pi. Okay, both graphs are both graphs are considered sinusoids. That just means that it can be written in the form of one compared to the other. So that means that I could technically translate this cosine and put it directly onto the sine. So both of those can be written as a function of sine, but we are going to get used to both the sine and cosine function. So here's the deal. Using what you already know about transformations, graph the following functions. So what I'm going to do is in red, I'm just going to kind of plot the major points of the original. Okay, so I'm going to do in red cosine x. So we know with cosine, again, if we go back to our idea of our unit circle, and I'm going to change this to be 1 and -1, we know for our unit circle, or if we go back to our original graphs, if we haven't gone anywhere yet, our x value, in other words, our cosine, is 1. And then we can go ahead and say my original, I'm going to restart at 2 pi. Halfway in between there is the -pi. And then halfway in between this value and this value is pi over 2, which is the 0. So it's going to cross there, cross there. So that's our original points. And then the same thing, if I go all the way to -2 pi, it restarts. -pi is the halfway in between, and then the zeros are in between those values. That's our original. Now what this tells us here is that this has been vertically stretched by 3. Okay, so instead of up 1, I'm going up 3. And so these points will be up 3. This point will be down 3. These points will remain the same. Same thing, -2 pi is going to be up 3 instead of up 1. -pi is going to be down 3 instead of down 1, and those points will be the same. So if we look at this, this is going to be our vertically stretched, okay? And keep in mind, our original looked more like this. And the reason, remember, the reason that our graphs here look more stretched out is because we changed that y-axis. Okay, we changed that y-axis. So here I went ahead and made the y scale be a unit of 1 instead of what I did in the examples that I did to start. Okay, so if we look at the next one, again, I'm going to do our parent function in red. So I'm going to do sine x in red. I'm going to kind of think ahead here, and I'm going to look that this is going to be vertically compressed a little bit. So I'm going to actually change my y scale to start just to make my life a little bit easier. So that's my original y scale. And so if I think about sine, if I haven't gone anywhere yet, remember sine is connected to my y values. So if I think about my unit circle, if I haven't gone anywhere yet, I'm right there. My y value there is a 0. So that's going to be 0. My restart point is 2 pi. Same thing over here, -2 pi. Okay. If I go halfway around, I'm at pi and -pi. Okay. Up here, pi over 2 means I'm up 1, so pi over 2 is here. And then down, this one will be the down. And then the same thing just kind of shifted over. So remember, this is going to be symmetric. Sorry, I had a little brain lapse there. There we go. So our original is going to look something like this. Okay. And so then when we look at our graph here, this has been reflected and also vertically shrunk by a factor, or compressed, depending on what word you want to use there, by a factor of 1/2. So that tells us this point, instead of going over and up, I'm going to go over and down. And instead of up 2, I'm going down 1. This point, instead of going down 2, I'm going up half that amount. So I'm going up 1. Now keep in mind, I'm saying 2. I'm just looking at the squares. Really, I'm going up 1/2 and down 1/2. I just changed that vertical scale. And so then same thing here. Instead of going down 2 blocks, I'm going up 1 block. Here, instead of going up 2 blocks, I'm going down 1 block. Again, remember, that's really halves. These are all going to be exactly the same along the x-axis. Okay, so now my graph is going to look something like this. Okay, so again, as you guys are looking at this, just kind of don't forget the things that we've already talked about in previous classes. The last thing here, this is actually pretty easy for most people. The amplitude, when you look at that whole entire function, you are looking right here at that number in front to figure out your amplitude. That is going to be the absolute value of A. So for example, if we look at the functions before, we're going to figure these out relatively easily because we are going to look here and here. So give me 1 second to fill in the gaps of as far as this amplitude box, and then we'll figure out the actual amplitudes of those examples. So the amplitude of the function here, again, we're just going to look right there, absolute value of A. Let me make this even easier for you guys. Graphically, the amplitude is half of the full height of the wave. Now, personally, I like to just look at the formula, or excuse me, the equation to figure out my amplitude, or the function to figure out my amplitude. However, this is going to come in handy if you're just given the graph and you're trying to figure out the amplitude. So I'll talk about that second, where I just started here in 1 second. Here, this is just telling us that we have an amplitude of 3. Whereas this one is telling us we have an amplitude, and remember, it is the absolute value, so the amplitude is 1/2. So let's talk about the graphs super briefly, okay? So if we look here, if this is a value that we've gone up 3, and this is a value that we've gone down 3, the height of this from +3 to -3 is 6. And so that tells us, if we're using this, that graphically the amplitude is half the full height. If that height is 6, that means the amplitude is going to be half of that. So again, when you guys are given the function, just look here. However, if you are given the graph, you have to do a little work and figure out the distance between the max and the min, and then cut it in half to figure out your amplitude. Okay, guys, if you are still struggling with the unit circle, please make sure that you speak up so that way we can get you the help that you need. That is absolutely vital to being successful in the rest of this unit. So please, please, please reach out. Let me know how I can help. Hopefully you guys are all tracking. Thanks.